Good afternoon, everyone. Uh, let's get started. Today we will see uh, how to use loops in C programs. So you can see this is a program which prints the tables. So if we compile this program, let's compile this program to start with. So GCC table.c. So like for example, if I enter 5, it prints 5 table on the screen. Similarly, if we print 8, it prints 8 table on the screen. So far we have seen, the code that you have seen so far, it is either a straight line sequence of code, or if you have an if statement, the code, like either the if part will execute or the else part will execute. But what is important is if you just have straight line sequence of code, you can do only so much. You will not be able to accomplish much. What gives the power to computers is ability to do a task repeatedly again and again. Like for example, the task could be, incrementing, or that the task could be like assigning a grade to a student. So the task there is assigning grade to, let's say, 10,000 students that are present. But every time the task is kind of invoked, it is on a different student. So if you have just straight line sequence of code, or if you have code, or if you have code where the control flows only in the forward direction, then what you can do is not really so much. What gives the power to computers is our ability to go back and repeat some task again and again. This is what gives the ability to power to computers. Someone enable their audio. Could you please? So if you look at this, we use what are called as looping constructs in order to do repetition of tasks. So here in this code, you can see line 11 to line 13. So in this code on line 8, we are reading the table that we would like to print using the scanf statement. And line 10 to line 14 is where the actual logic for this program is present. We are using a variable I is equal to 1. So we are initializing that variable to 1 on line number 10. We are checking if this variable I is less than or equal to 10. If it is greater than 10, then what happens is control comes out of this loop. If it is greater than 10, if I is greater than 10, the control doesn't enter this loop body. It jumps out of the loop and goes to the statement that is after the loop. But on the contrary, if that Boolean condition is true, the statements within the loop will be executed. So here we are starting with I is equal to 1. So what happens is, so 1 is less than or equal to 10. So we go to statement 12, we print, so when I is equal to 1 and when we enter, what happens is the value of n, let's say if you enter value of n as 5, then you kind of, when I is equal to 1, you kind of print 5 times 1 is equal to 5. That's what we are doing. So this n corresponds to this percent d. this corresponds to this, and this n star I corresponds to this. This is how the whole thing is printed. And then again we increment I by 1, and then you go back to statement 11, and then again we check if I is less than or equal to 10. So if I is not less than or equal to 10, then you come out of the loop. And if it is less than or equal to 10, you go and execute the statements of the loop. This is the syntax of the while statement. And if you want to see, we can do a GDB on this program and see how it is working. So GCC -g table.c. So here, let's say we put a break on main. We say next. Oh, okay. Say run the program. It is asking for the input here. Let's say we enter 5. So now the control is on line number 10. So the control is on line number 10. So after line number 10 gets executed, you can see if I print the variable I is equal to 1. And if we kind of say print I less than or equal to 10, so it's a true statement. So the value of this Boolean expression is 1. So when we execute the next statement, the statement that is there on line 11, so that condition is evaluated and that condition turns out to be true, we enter the while loop and we execute the printf statement. And so you can see the output of printf is printed here. And the next statement after printf is the statement on line 13, which is I is equal to I plus 1. So that Aditya has this question, what is this dollar? So I'm not sure. I think GDB uses some naming convention to hold written values of expressions, I guess. I don't know. Please check. So let's not get into that right now anyways. And so now again, so if you see print I, you can see the value of I is 2, and we have come to the beginning of the loop. And then again, if we see if I is less than or equal to 10, then again it is true. So we enter the loop. So we execute the statement printf. So 5 times 2 is equal to 10, I is equal to I plus 1, so on and so forth. So let's keep going like this. Let's continue this loop and see what happens. There is a question. I will answer that question in a moment. 5 times 525, 5 times 630, 5 times 735, 5 times 840, 5 times 945. So 5 times 1050. So now 5 times 1050 is printed, and if you see, if you execute print I, the value of I is equal to 11. So if you check if print I is less than or equal to 10, then you will get a 0, because I is not less than or equal to 10. It is a false. False is nothing but 0 in the context of C. So now when we execute this statement, we come out of the while loop. That's what happens. Are you all with me on this program? How GDB, how we are able to go through this program using GDB? So someone raised a hand, so they can unmute themselves and ask a question.
Hello, sir. Am I audible?
Yeah. Can you introduce yourselves?
Sir, I'm Sujit Mandava.
Okay.
Yeah. So I've noticed something, like in general, whenever you display program codes to us, the syntax tends to change a little. Like for example, over here it says void main void, and other times it's int main and there's nothing in the bracket, or there's void sometimes.
Okay.
So what is the best practice like because I'm a beginner, I just want to know what the best practice like when we are coding is in like a syntax flow.
Best to practice is for the time being, don't worry about it. Bad answer, but you can just use void main void. Sometimes we use the written code from the main function in order to do something, but we are not there yet. So you might as well use void main void because the written value is not being used. We are not passing any parameters. So in the absence of any other things to which can bother us, this seems to be a good practice.
Okay, thank you, sir.
So now let's do the same experiment. Now this is how a while statement works. And so with this, you are completely empowered in the sense you can do what are called as any computable function. You will be able to write a program using all the constructs that you have seen in this course. So you have reached a very critical point in this course. And so now you know all the constructs pretty much that are essential to write any arbitrarily complex programs. Tomorrow you will see, I will introduce you to arrays, and after that you are good to go. So you are completely empowered to do many, many interesting problems. So now we will see the same problem. We will solve it using uh, a for statement. So in the for statement, again on line 7, line 8, we are reading the input. And on line 10, you will see the for statement has 3 parts in it. And so this technically this for statement, if you want to rehash it into a while statement, it is something like this. I is equal to 1. So, and then while I less than or equal to 10, whatever the body of the for statement, you just have it. And then finally plus plus I, you write. So the code that you are seeing on line 10 is equivalent to the code that you are seeing on from lines 14 to 18. So in order to make it complete, I can say like this. So the code you are seeing from line 10 to 12 is equivalent to the code you are seeing from line 14 to 18. That is, whatever you have before the first semicolon, it will be executed before the for loop gets initiated. And the body of the for loop will be executed if this Boolean condition is true. And after the body of the for loop is executed, whatever the expression that is present here, it gets executed. So you start with I is equal to 1. You check the condition if I is less than or equal to 10. And then so printf, whatever the body of the loop gets executed. And then after that plus plus I gets executed. And then you go back. So this is the semantics of the for loop. So there are a couple of questions. There is one question is for loop faster than while loop? No, not like that. So there is something called as syntactic sugar in programming languages because there are few students who are having questions. I'll get to you. So remember this word syntactic sugar. So underneath it, that really doesn't matter. Because from the compiler perspective, all these things, they don't really matter. They get transformed to a form which is kind of neutral to for or while in a sense. In this particular case, ++i or I++ doesn't matter. In this particular example, it doesn't matter. There are a couple of few students who have questions. You can unmute yourselves and ask. Before that, there is no advantage in using for versus while, but for statement, as you can see, it is slightly a shortcut. It can write less code and express the same logic.
Good afternoon, sir. This is Karthik Ashwath.
Yes, Karthik.
So, can you tell me where is this I? If I initialize this I inside the for loop in the initialization statement, if I use
No,
int
not
I,
inside the for loop. Just before, the semantics of the for loop is initialize the variable I is equal to 1. Okay.
okay,
And
sir.
then after that, check the condition if I is less than or equal to 10. If that condition is true, execute the body of the loop and then increment the variable ++i, whatever that is given ++i, that's what is being executed.
No, sir.
And then again go back to the beginning of the for loop and check the condition. So
Yes, sir.
the initialization statement I is equal to 1, it has effect only once, but the Boolean condition is visited every time we iterate.
Yes, sir. That part I understood. What I wanted to ask was maybe I didn't convey it properly. But what I wanted to ask was if I use int I equal to 1 within the initialization of the for loop.
Mm-hmm. Okay, got it. Yeah.
So will
I didn't
that
get your
be in the
question.
block of the for loop or will it be in the main block?
Got it. So wait, I think let me see if I got your question right. Before I answer your question, are you all with me on the for loop? Are there any questions on the for loop? I just want to check.
Yes, sir. I have a doubt.
Yes.
Hello.
Yeah.
Yes, sir. So when I'm using a for loop, so do I have to write I is equal to 1 before I is greater than equal to 10, or I can write I is greater than equal to 10 before I write I is equal to 1?
No. What the way you have to write is exactly the way I'm showing it on the screen. We have to, whatever the statement that is here, now it is like kind of setting up the stage for the for loop to execute. So that is the initialization part of the for loop. So you have to do it first.
So
Sir,
in
I
the
have a
first
doubt.
part we meant so in the first part of the for loop we write I we give I and give I a value, and then in the second part we mention the condition. And for the third part we can use any sort of a function or whatever we want, like either increment it or multiply it or something.
Yeah, that's true.
Right, so that's okay. Thank you, sir.
Yes, Ame?
Sir, I had a doubt. I wanted to ask that when we execute this program, it will instantaneously list the table of five, right? Or whatever number we
Okay.
put in. But what if I wanted to go step by step? So, like five ones are five, then wait 1 second, then five twos are 10. And what if I want to delay my code because the computer's power is okay, sir.
You can put a sleep statement and GCC.
So I don't think sleep works in this compiler.
Or is it?
You need to use usleep.
No, it is working.
Oh, okay. It didn't work for me. I don't know.
Yeah, so
I
you
use
can.
usleep, so
Okay. What sleep you use? What statement?
the
Use
the
sleep.
microsecond one.
Oh, okay.
Uni STD.
Oh,
Usleep.
okay. Yeah, sleep should work. Yeah, I I have to include the appropriate file for sleep, and but I didn't. But the compiler took something default like this. What the parameter to sleep is the number of seconds uh, the program should sleep. So now you can see the delay is more.
Yes, sir. Thank you, sir.
Not for the sleep program. For the sleep function, it takes time in seconds, not in microseconds. There could be some other sleep function, but this sleep function, it takes in seconds.
Hello, sir.
Yeah.
Sir, what is the use of using sleep in our program?
It's just to delay the printing. So whenever the statement hits that sleep, the program sleeps relinquishes the CPU for that much period of time. Like for example, the code keeps executing like this, and at some point it hits a sleep statement, sleep one. So it relinquishes the CPU for 1 second, and then after that it makes itself available for using the CPU processor. And if you say sleep 3, then it's bad. Whatever the time that you say, let's say 10, then the program goes to sleep for 10 seconds, and after 10 seconds, it makes itself available for using the CPU.
Sir, I had a doubt. Am I audible?
Sure, yeah, please go ahead.
Sir, in the line 10, where you defined the for loop, you have defined the variable I is equal to 1. Then you have defined a condition for which the for loop should run. And sir, I did not clearly understand what the third part is, that plus plus I.
See, that plus plus I, the way to think about it, I think, as I said before, this program is, this code is equivalent to, this is what I want you to pay attention. Generally speaking, the for statement, it looks like this: E1, E2, E3. So this is how the semantics. E1 is some expression, E2 is another expression, E3 is another expression. So this whole code, this is equivalent to, there's an expression E1 that gets executed before the entering the, and then while E2, so whatever the body of the loop, let's say I use different color to, so this is the body of the loop. This body of the loop is present as it is. And then here you have E3. So so this code, the for loop code, so it's, you know how the semantics of while loop is, right? So if you want to understand the semantics of for loop in terms of while loop, this is how the semantics looks like. Does it make sense or?
Yes, sir. Yes, sir. I understand.
Okay.
So why does sleep work without including the correct header file?
I think the compiler is guessing what header file it is because it's a very common function.
But like with math, the math functions, it didn't include it, right?
Yeah, I don't know. Good question. So, yeah, I don't know how sleep is. But if you compile it without, it is complaining, na? So implicit declaration of sleep. So whatever that implicit declaration, it is compiling. Yeah, it is giving a warning and compiling, but I'm exactly not sure how it is able to get hold of sleep.
So does that mean it's including uni std on its own because of the implicit declaration?
I don't know, not because of that, but I think some standard function, what is happening inside, I don't know. How compiler is, yeah, so now
Okay,
that
yeah, now
warning,
it's not giving warning.
yeah, now it's not giving warning, but without that, it is assuming something, and it is saying, I am assuming something, but don't complain if it is, if my assumption is wrong. So.
Sir, I think that sleep only belongs to one particular library, right? So it's already like, since it belongs to one library, it's just assuming that library, like taking that library on its own.
Well,
But sleep is a non-standard function also.
Yeah, anyway, let's not get too bogged down about
Sleep
sleep.
is a POSIX.
Sorry?
It's POSIX, not standard.
Yeah, so it's okay. So let's, yeah, I think. So here there is this question, I plus plus doesn't matter in this case. Because if you see, if this code gets translated, if this code is equivalent to, this is what I said, I is equal to 1, while I less than or equal to 10. So here I want you to think in this particular way, because there is this question on whether plus plus I or I plus plus matters. Because the value returned by plus plus I or I plus plus here, it is ignored, it is not used. So here, like similarly, we will have this is equivalent to this. So on line 18, so line 18, it returns a value and there is a side effect. What is the side effect? The memory location associated with variable I is incremented. So what happens is it really doesn't matter whether you do plus plus I or I plus plus, because the return value is ignored. So you don't worry about it, whether you use plus plus I or I plus plus. Great. So let's go to the next piece of code, which is on computing log. So this is a program which computes log of a number, but it so like what it does is so if you enter, so here on line 8 we are entering n, and on line 3 we are defining a base. So what we are computing is log n to the base 3 floor. This is what we want to compute. And so what is this? So what is log n to the base 3? Log n to the base 3, for example, is 3 power k such that largest value of k such that 3 power k is less than or equal to n. Are you with me on this one? This is an important thing. What we are trying to do in this code, in this while loop is, we are reading n and we start with, I is equal to, so initially we check if 3 power 0 is less than or equal to n. 3 power 0 is 1. Okay. And then after that, what we do is, here you can see log is equal to 0. Log is equal to 0. And then after that, what we do is we check if 3 power 1 is less than or equal to n. After that, we check if 3 square is less than or equal to n. After that, we check if 3 cube is less than or equal to n. And every time we are incrementing this log. What is the log? Log is exponent. You are incrementing the log. And finally, let's say if 3 power 4 is greater than n, so the log value is already now is equal to 4. So what we are printing on line 21 is, we are printing that the log of the number to the base 3 is equal to 3. That's what we are printing on line 21. Are you all with me on this code logic? Okay, so let me repeat again. I think some of you may have a problem. So what we want to do is we want to compute log n2. So we want to compute log n to base 3, where n is given as an input. I think first let's run this program before I clear it. That could be a good thing so that you know what it is. GCC log.c. So let's say 3, log 3 to the base 3 is 1. So if it is 4, log 4 to the base 3 is 1. Because why is it 1? So it is 1 because 3 power 1 is less than or equal to 4. And if you look at 3 square is greater than 4. And this is what we are looking for. What is the smallest value of k? So we are looking for smallest value of k.
Excuse me, sir.
Or largest k such that 3 power k is less than.
Excuse me, sir.
Yeah.
Sir, instead of integer, if we use float, then we will be able to. So, like the higher the more the decimal places of the float, the more accurately we'll be able to.
No, we are not interested. That's not the point of this problem. We want to do something largest k such that 3 power k is less than or equal to n. This is what we want to find. So I understand your point, Gaurav, but right now we are just interested in computing this. We want to find out what is the largest integer k such that 3 power k is less than or equal to n. And what we are doing is, so there is a question. So can you try 81? 81 is 82. If you put a very large number for rent, see these questions on the point of this example is not what if we use a large number for rent. You should try out. I want to illustrate a different idea using this example. So we should not keep on looking at the same idea no matter what example you see. The purpose for this example is different. I want you to understand how we can use while loop to solve some problem in a nice way. We don't want to use float. There are other ways to do it. So all I want you to understand is the problem at our hand is we want to find the largest value of k such that 3 power k is less than or equal to n, where n is an input number. So what we are doing is, in order to solve this problem, what we are doing is we are starting with I is equal to 1 and log is equal to 0. And what is 3 power and what is actually I? I is the invariant that we have is I is equal to 3 power log. I is equal to 3 power log. So what happens is in the next iteration, we use I is equal to I is equal to 3 times I. So log becomes log plus 1, so on and so forth. So let's look at the code again, so that it becomes easy rather than here, so you can understand what's going on. Let's go to the code. In the code, you can see I is equal to 1. In every iteration of I, we are multiplying I with base. And log is incremented by 1. And we keep doing it until I is less than or equal to n. So if you see here, this is what I'm trying to explain. So here, I is equal to 3 power log. And the current value of log is equal to 0. And the current value of log is equal to 0. After the first iteration, what happens is I is equal to 3 star I. But the other way to look at is I is equal to 3 power log and log is equal to log plus 1. But log earlier is equal to 0. So log now is equal to 1. So I is equal to 3 power 1 and log is equal to 1. So this is what we have after the first iteration. After the first iteration, we have I is equal to 3 power 1 and log is equal to. And after that, what happens? I is equal to 3 square and log is equal to 2. This is how it goes. Are you all with me on this logic? I think it's reasonably easy. Shall I go ahead then, if you're all doing good? So that's all. So after some point, what happens is you hit a value of k. When do you come out of this loop? You hit a value of k where 3 power k is greater than n. At that point, you exit from the loop. And actually, what is k? This is k is nothing but the log. Okay. So here on line 21, you just print that log value. That's all. So let's move to a different code. I think we are good here. So you can revisit this code one more time and see what's going on. I want you to, there are good questions here. I just want to use this example to see how we can use while in a clever fashion. But questions such as how can we use float, or what happens if the value of n becomes large, all those are valid questions, but let's not try to answer those questions in this example. But you can try out these examples and see what happens. Now let's look at some more code. Yeah. So this is the code that we have seen some time back. So here, this statement keeps executing forever because one is true, while true do nothing. But do nothing also involves executing some instructions. So if you see GCC in while, so this thing we have seen before. If you do htop, and if I say dot a dot out, you can see that simple program a dot out. Yeah, so now we are good. Yeah, so if you see this, if you do a htop, so this is the current utilization of CPUs, and if you say dot a dot out, and if you go here, you will see one core number 6 is being occupied. So it is busy doing nothing. Okay, the while loop. So this is what we did, and we can even so an equivalent thing, for example, even for also does the same. I think, yeah, I think here we may have to use one. I'm not sure. I think maybe you have to check. You'll check what happens if you just use for loop like this. I'm not sure about it. Please check it once. But for while loop, the semantics is very simple. So this is one example, and let's look at few more examples. Table. Yeah. So now take a look at this program numdigits.c. This program contains what is called as a do-while statement. And this program, the property of this do-while statement is the body of the statement will be executed at least once. Whereas in a while statement, the body, you may come out of the while statement without executing the body of the statement even once. So here in this program, what is the logic here? So let's say if n is equal to 231, so you enter this while loop, this do while loop once, and then when this condition is being checked, what happens is the value of n becomes 23. And you check if 23 is greater than 0, so 23 is greater than 0, so you go back again, and then what happens is you divide 23 by 10, so the value of n becomes 2. And then you come again here and you check if n is greater than 0. So n is, 2 is greater than 0. So you go back again. So, and then you say n divided by 10 and n becomes equal to 0. So you go through this loop at least, and when n becomes equal to 0, of course, you come out of this loop. So you enter this loop for when the value of n is equal to 231, when the value of n is equal to 23, and the value of n is equal to 2, and the value of n is equal to 0. That is, when you enter the loop with the value of n is equal to 2, you come out of the loop without jumping back. Are you with me on this example? Do you understand the semantics of the do while statement?
Sir, could you explain it once more?
Yeah, so can you tell me what's the thing? So what happens? So let's say you read the value that you enter is 231. So the value that you enter is 231. So initially the value of n is equal to 231. You enter this loop, and so n becomes, you divide n by 10. So 231 divided by 10 is 23. It's not 23.1, it is 23. And the digits gets incremented by 1. So in the next iteration, n becomes 23. And in the next iteration, n is equal to 2. And if you see, in the iteration where n is equal to 231, at the end of the iteration, digits becomes equal to 1. At the end of this iteration, digits becomes equal to 2. At the end of this iteration, digits is equal to 3. And at the end of this iteration where n is equal to 2, 2 divided by 10 is 0. You go and check this while statement and you come out of the loop because that condition is not satisfied.
Okay, thank you, sir.
Does it make sense, Pallav, or does it?
Yes, sir. But like, is this just another method to write a logical loop? Like,
yeah, that's true. But there is this method has a slight its difference, that this loop will be executed at least once.
Sir, can you explain the part where it comes out of the loop again?
So let's say if n is equal to, yeah, let's do a GDB actually, so that it becomes, this is a good case for GDB. So gcc num digits.c. GDB a.out, break main, run, next. So enter a non-negative integer. Let's say 231 is what we entered. What happened? It ran completely. Okay. I didn't use GCC minus G option. So just follow along with me on this gdba.out, and so I'm putting a breakpoint on main, run, next. So scanf, I'm entering 231. So after this, you can see what is the value of n. The value of n is 231. So you can see the code directly, there is no Boolean condition which checks to see whether we should be entering this do while statement or not. So the control enters this do while statement at line number 14, and that's what GDB is telling. That the next instruction that is going to be executed is 14. But 231, this, what is n divided by 10? This is nothing but n is equal to n divided by 10. So 231 divided by 10 is 23.1 if you do floating point arithmetic. But in the integer arithmetic, the float, whatever that is there after the decimal part, it gets truncated. So the value that will be present in n after statement 14 gets executed is equal to 2. So if you see what is the value that is present in, it is 23. So if you print 10, it is 23. And you have incremented digits. So there is one digit you got. So you have incremented digits. So if you print digits, we didn't still increment it. So now we have incremented it. So if you see print digits, it will be 1. So now the next statement that we have to execute is statement that is there on line number 16, which checks whether n is greater than or equal to 0. The current value of n is equal to 23. So 23 is in fact greater than 0. So what happens is you go back to the beginning of the do while loop, right? So now you say n is equal to n divided by 10. If you print 10, you will see the value that is present in n is 2. All right. And so you increment the digits. Now you check whether 2 is greater than or equal to 0. Yeah, 2 is greater than or it is in fact greater than equal to 0. So the control goes back to the beginning of the do while. And what is the value of current value of n? It is 2. So 2 divided by 10, it is 0. So if you see what is the value of n, this is n is equal to 0. So let's keep going. So now we check if n is greater than 0, but n is not greater than 0. So we come out of the loop. And when we come out of the loop, you print the number of digits that number has. Are you with me here? Does it make sense? Are you all with me on this example?
Yes, sir.
Yeah, it is possible to use GDB to debug directly from the assembly code. Yeah, it's can we write n is equal to n by 10 in place of course, Rachit, you can do that. See, do while statement is very similar to the while statement, except that in the case of while statement, you may not execute the body of the loop even once. But in the case of do while statement, the body of the while loop will be executed definitely once.
Sir, can you explain this part?
Sorry?
So this while statement does not execute it even once, but do will execute it at least once.
See, in the while, yeah, okay. So let's see again. Let me write. So the previous program is, let's see. Yeah. So if you use some, let's think of it this way: do while some expression. This is the code. Here, what happens is the body of the loop will be executed once, and then this condition is checked. And if this condition is true, then you go back to the beginning of the loop and then again execute the body of the loop. And if this condition is, again check if the expression E is true or not. This is how do while loop executes. So because of that, it is essential to in that the body of the do while loop will be executed at least once. Are you with me on this one at least?
Yes, sir, I understood.
Excuse me, sir.
But on the contrary, if you look at the while statement, the while statement is while expression this. So if this expression is true, then you enter the body of the loop and then you go back to the beginning of the loop. So in this case, it could so happen when you evaluate this expression for the first time, it could be false. And because of that, you don't execute the body of the while loop, not even once. Do you see the difference between while and do while loops?
Yes, sir. So, I mean, like if we enter a single digit number and it divides it by 10 and you get a 0 value, so it'll say the number of digits is 0.
If you give a single digit number, then the number of digits will be 1.
I mean, if you use only a while loop.
Yeah, that's true. That's true.
Okay,
If you use a single digit number, then yeah, you have to, that's true. If you do that condition, it becomes a problem. Yeah.
Okay, sir.
Excuse me, sir.
Yeah.
So this is an unrelated question, but I plus plus, does I have to be integer in I plus plus?
No, no, it's not necessary.
Okay, sir.
I plus plus, it's again syntactic sugar. So I plus plus is nothing but I is equal to I plus 1. So I can be an integer or floating point number, it doesn't matter. It's a syntactic sugar, as they say. I can even be a character, I think so, yes. Now let's look at one more program, sum.c. Yeah. So in this program, so we enter a series of numbers and yeah, we just sum up all the numbers. And when in the series, if we end 0, then the series will end. So let's compile this program and see how this program works. So gcc sum.c.a.out 23 minus 23 0, for example. So you can see, so 23 plus minus 23, when it sees 0, you come out of the loop. So here, how, if you can check this program, in this while loop, we are reading numbers one after another in this while loop. And whatever the numbers that we are reading, we are accumulating them in the variable sum. And when we read a 0 from the input, you come out of this while loop. Are you with me on this simple program, this sum.c program?
Sir, is this a basic addition calculator?
Yeah, this is nothing but sum of, we are just computing the sum of numbers. Yeah. Any questions you have here? If anyone has any questions here, please.
So I didn't get how the loop was terminated.
The loop is terminated when you enter n is equal to 0. When you enter a 0, it gets read into the variable n. And on line 11, so we are checking if n is equal to 0 or not. You continue the loop only if n is not equal to 0. If n is equal to 0, you come out of the loop.
Understood, sir. Thank you.
Now let's look at one more program, max.c. Yeah. So this could be an interesting example. Someone asked, can you show me the code again? So actually what I will do is, I think I will stop here because it's important that you get enough time with your TAs in the lab session. After I show these two examples, I think I'll stop here. So I'm showing the sum.c code again, Anirudh. So you want to ask any questions? Two things that So two things that I would like you to make a note is, we are accumulating the sum in we are accumulating the sum of numbers in a variable sum, and we are initializing that variable to 0 on line 6. And we are accumulating the sum in line 13. Every time we read a number, we are adding that number to the variable sum. Great. And here, yeah, so here what do we have? This is a program to compute max. This is yet another interesting example. In this example, what are we doing? We are, yeah, so we are assuming that the variable max contains max. So we are holding in the variable max the smallest value possible. And the macro for the smallest value possible in an integer is int underscore min. So here we are starting with a hypothesis. We are starting with a kind of a setting up the stage by taking the smallest possible number as the maximum number. And then in the loop, if you see the line 13 to line 18, you read a number and you check if that number is greater than max. And if it is greater than max, then that number, then the new number becomes the max. Format document. Then the new number becomes max. So like that, so you start with an initial estimate of the max, and as you keep reading the input, your estimate of the max keeps improving as more input is read. So if the current value of the max is 10, and if the next number that you read is 8, then the max 10 remains the same, but the next number that you read is 12, then the max gets improved from 10 to 12. Right, so let's run this program and see. So this is, I want you to understand a couple of things. We have seen two techniques in sum.c and max.c programs. In sum.c, we are reading values and we are accumulating them in a variable. In max.c, in this particular program, we are using a logic where we are saying that we have an initial estimate of the max, and we are, as we keep reading numbers, we keep improving our estimate. So these two are two interesting approaches to solve any problems that you face in programming. So GCC max.c 23, 43 minus 12. Let me do this. Minus 12, minus 13, minus 40, 0. Are you all with me on this example? The logic for this program. When we see 0 here, so in this input series, 0 is not allowed, because when we enter 0, we are saying that the series is terminating when we say that the input is 0. So we cannot enter, we can enter 0 only to tell the program that the series has terminated. Int underscore min we will see later, but it is the smallest possible integer that you can store in a variable, in an integer variable. We will see what it is in a later class, but for the time being, int underscore min, it is a macro which holds the smallest possible integer. Are you with me in this example? So we want to read numbers again and again, right? Because if you don't have the scanf in the while loop, how do we read numbers?
Sir, can I ask a doubt?
Yeah.
Can you go to the terminal once to execute the program, sir?
Yes.
Can you execute it once? Can you just put one number and press enter?
Okay.
And can we enter like this, sir? Like
yeah.
So we can keep on pressing enter and.
Yeah, because you understand when we were studying scanf,
yes,
all these things will go to the keyboard buffer.
Yes,
and
yes.
/n is a kind of a white line character which scanf will ignore. So
yes,
it's not an issue.
Understood. Thank you.
I think we should conclude today's session here. Tomorrow we will continue our discussion on this. I will also introduce arrays to you in the next class.
Sir?
Yes.
Hello. Sir, I have a doubt. So the first scanf, what's the difference between what the first scanf is reading and the second scanf inside the while statement is reading?
No, so before we enter the loop, we want to read at least some value. That is how you're setting up the logic. You want to read a series
so
of
the
numbers.
First value.
Sorry?
So the first number that we, so like for the first scanf, we enter, like the first number we entered is read by the first scanf.
Yeah, that's
then
true.
we enter the while loop.
Yes, yes.
And after the first number is read, we enter the while loop.
That's true.
Or do we enter the while loop after all the numbers have been added?
No, it's not like that. So we enter the while loop. See, what is the logic for the scanf? the logic for scanf is after you enter in the keyboard buffer, let's say if you enter, so in the keyboard buffer, so you enter 12, 13, 14, whatever the numbers that you enter. So this 12 will go to this particular scanf, and this 13 will go to this scanf for one iteration, and this 14 also will go to the scanf in the next iteration, so on and so forth.
And how does it know when to terminate? So after for the 0, okay.
Yeah, after when n is equal to 0, so it terminates.
So it terminates the while loop then.
Yeah, that's true. It terminates the while loop.
Sir?
Thank you, sir.
Yes.
So basically it keeps updating the value until 0 appears in your list.
That's true. Yeah, when 0 appears, the 0 also will be read into variable n, but it comes out of the while loop.
Okay, sir.
Sir, I have a doubt, but it's from a different question.
Okay.
So in one of the programming assignments, we have to reverse a number that can be of 1, 2, 3 or more digits.
Okay.
So if the input is 100, do we have to output 0, 0, 1 or outputting 1 will be fine?
Good question. 0, 0, 1, maybe.
Okay, sir. I actually coded that, but then I got confused because
maybe
it was
0,
not mentioned.
0. Yeah.
Thank you, sir.
All right. I think we will conclude today's session here. Thank you all. I will see you tomorrow morning. And please take the help of TAs. We have a great set of TAs. And any doubts, get them clarified. So someone raised a hand. So you can, if you are done, you can kind of leave this session and join your TS for the lab.
So earlier I had asked about the scope of the variables.
Oh, okay. Yeah. So tomorrow morning I'll explain because it's an important idea. Everyone should listen. Okay.
So what is int min? Sir, int underscore min over here.
Sorry.
So what is int underscore min?
Oh, that int underscore min, it is a macro defined in limits.h, which tells the smallest value that you can store in a integer variable.
So how what's it doing in the if loop? Like n is greater than max, what is it comparing it with?
So the value, whatever the value of n that is read on line 12, you are comparing it with the max value. Initially, let's say maximum, the int underscore min, if it is equal to, let's say, minus 1 lakh for the sake of simplicity. Okay.
Okay.
So you enter 12, you compare 12 with minus 1 lakh. So 12 turns out to be max. So on line number 16, you will say max is equal to 16.
Okay.
And then the next input that is there in the input keyboard buffer is 32. So you compare 32 with the current max, which is 16. So you update your max to 32. And let's say the next input that is present in the input buffer is minus 12. So you compare minus 12 with 32 and no, it is less than 32. So you don't need to update your max.
Okay, sir, I got it. Thank you, sir.
So like that, you keep going. So you have an initial estimate of max. What is our initial estimate? It is what is there on the line 8. And we keep improving our estimate as we keep reading the input.
So if I don't use int min, I use 0 instead. I say n is greater than 0, it will have the same effect.
No, it will not have it, because if you enter negative numbers, then yeah, negative numbers, if all are negative numbers, then you know that then what happens is you will print 0 as the max.
Okay, sir.
Because let's say the input is minus 20, minus 30, minus 12, etc. So you never improve the estimate of your max because you are thinking 0 as the max.
Yes, sir. Okay, thank you, sir.
Sir?
Yeah, sure. You can all leave. So it's all done. This anyone, I'm just clarifying questions for students. So please, you can leave and join your respective tutorial sessions.
Sir, I have a doubt.
So Frame has this question, when do we learn assembly language? In this course, we don't learn assembly language Frame. You learn it in computer systems organization course, which is in the next semester.
sir.
Yeah.
Initially we are assigning n and max to a value int min.
Not n and max, only max.
Okay, so we are defining a variable n and we are giving max the value of int underscore min.
Yeah.
Then we are scanf asks us for a value and we are giving a value of n. And that value of n is assessed in the loop here that is defined. Then if our number is greater than max, that number is assigned as max.
Yeah.
Then it is asking for another value of n.
Yeah, next input in the series. Yeah.
Then it like the loop goes on like this, right?
Yeah, that's okay. Yeah. Vikram, so what is your question? We don't have to use, why do we need to use a getChar? Because we want to read integers. I didn't get your question, Vikram. You asked it a couple of times. I think Vikram left. So, okay. I think we'll stop recording.